So in this session, we want to have a quick chat about how to perform calculations of these parameters called mean and variance of measured data when they are grouped together. Now, why do we group them together? If you're the author or presenter of these data, which can be huge, right? It may not be 9 values. It may be, hundreds of values or thousands of values that you don't want to swarm the audience with, because what's the point, right? You want to show the main takeaway rather than swarm them with the data. So when you want to show the data but not overwhelm people with data, you might want to show them in a tabular form. Yeah, so tabular form is good and not good. It's frequently used. You will see a lot of these in reports, in analysis, in various settings, right? From stock market to consumer reports to company performance and so on and so forth. So it's good because it is very readable. No matter how wide-ranging the measurements are, it can be from 70 to 120, like almost twice. It can be from 70 to 7,000, right? So it can be from 7,000 to 70 million. So it can be very wide in the range of the data span. And the frequencies can be very large, but it is very easily readable when you group them in ranges like these appropriately, and then you show just the number. Right? So when we present it this way, it is both uh, readable, right? It is quite readable. If this is about age, then 70 to 90, one person, right? 80 to 89, nobody, and so on. So it's quite readable, it is quite meaningful, but it is less accurate, right? So if we start asking, like going in more in depth, how many of those from 90 to 99, the two of them, are they closer to 90 or 99? So if your range is too wide, then you might prompt this kind of questions about, can you tell me more about this range, right? So yeah, why not? Because when people are more interested, then you give them the details about that range, right? But if they're not, just like they skip past 70 to 79, 80 to 89, then you don't talk about them, and that's good. So additional details and resolution as people are more interested in certain bins, as we call them, these vertical segments. Now, also more frequently, we'll show a histogram, right? So vertical axis is always frequency. That defines your histogram, right? Vertical axis is always frequency or relative frequency, and horizontal axis will be the measured values, the x itself. So if it's stock price, then it's 70 cents to 79 cents. If it's height, then it's 70 cm to 79 cm. If it's weight, then 70 to 79 grams. So the ranges of measurements will be on the x-axis, vertical axis, either frequency, the actual count themselves, or relative frequencies in terms of decimal places or percentages. So that is the idea. I mean, that is the reason why we do group data. Now, what if you were given group data? Suppose you were given this table here instead of the raw data. We call this the raw data because you get individual access to each number, even when they are repeated. Look at 101 here, right? Even when they are repeated, they are shown exactly and precisely. So you get detailed calculations. We have done that just now. So what if somebody already grouped them because they don't want to annoy you with a lot of detailed data? They give you the table. All right. So even though you would prefer raw data because it's quite easy to calculate in Excel and other packages, right? But what if you have this? For example, you flip to a page in the library, a particular book, and the book shows this data. You're very interested in this table of data, and you want to calculate the mean and variance. The book didn't show you that. How do you do it? So obviously you don't have access to the raw data, right? And yet you need or have a desire to know the mean and variance of this table of data. How do you go about it? So the idea will be you first add up the actual uh, amount, right? So x1 75, but 70 to 79, which number should you use? So the typical uh, unbiased selection of the representative value will be to take the midpoint. So here we do a 75, all right, and for simplicity, because we could also do 70 plus 79 divided by 2, although there may be a problem because from 79 to 80, if it's continuous, we might lose one whole segment there. So more correctly, 70 plus 80 divided by 2, so 75, 85, 95, and so on. So these are the representative values of the range here. Now notice that here when we select a representative, there's already a loss of resolution of the data. It's a bit like a photograph taken with high resolution camera, but when you process it, you kind of down resolution it to kind of pixelate it a little bit more, so it kind of looks coarser, and that's the idea here. Look at 101. 101 appears pretty frequently, but when it's bin together, it is just 5 counts of someone within 100 to 109. And when we take the representative, it's a bit biased upwards, right? But we have no idea that original value was 101, and it now becomes 105. So don't be surprised that the mean and variance that you calculate from the summary table will be different from the mean and variance if you had real access to all the actual individual data. They will be different because of grouping them together and the selection of representative. So given the table, the question is, how do we calculate the mean and variance? So very simply, we add up, all right? 75, it's repeated one time. 85, nobody was there, times 0. 95, repeated twice. 105, repeated 5 times, and all that. So that leads us to x1 times f1. That's number 1. f2, f3, f4, f5. So in symbol, we write summation 1 to 5, x1 times xi times fi, you get this. Then take the mean, divide by the total number of items, which is sum of all the fi's, right? So that's 9, so we divide by 9. This is mean, so we can do the divide by n itself. But when it comes to variance, then we divide by n minus 1. Again, we use the formula, but all the xi's will be represented by the class representative, we call it, right? It represents the 75 represents this class of values. So 75 minus the mean, which we have calculated above here, all right, and then square, then times fi, and we get this. Then taking the square root, we'll get it. Okay, so just very quickly using Excel. All right, and again, I want to show you how from scratch how we can do it. And the cost, the main idea here is the class representative. So I'm just going to dispense with showing the original numbers. So what is important is the class representative and also the frequency. Okay, so the fi's 1, 0, 2, 5, 1. So we can do that very quickly. Okay. So next, what we want to do is to calculate the mean. So the mean of sample, x bar, better remind ourselves, is going to be, okay, we can actually sum up this, but we cannot, I mean, we can actually sum up the 75 times 1 plus 85 times 0. But one easier way to do it is to use Excel sum product, which allows us to just swipe this, comma, swipe this. And so long as the size of the rectangles are the same, Excel knows that the first cell, first blue, is to multiply by the first red, plus second blue times second red, plus third blue times third red, and so on. So this will be just nice. And if we sort of take a quick peek, we get 905, which is exactly this number here, right? So we're not done. We just divide by the count of, no, sorry, we're going to divide by the total frequencies, which is here. Okay, so the sum product and divided by the total frequencies. Yeah, all right. And we might actually want to have a total frequency written out separately because that might be useful later. So we can then divide it by this value itself, which is the same. So we get 100.5556, and that's our mean. Then let's calculate the variance. Yeah, variance is the difference from the mean squared times fi, then divide by n minus 1. So, so the variance is, we need a separate bracket xi minus x bar square, right? Just like what we have done earlier on. So this minus the x bar, and we want to lock it, otherwise the red box will start shifting down when we paste it. Then we close it and squared. Okay, so this is the xi minus x bar square, and we repeat it across downwards. Yeah, okay. And then we have this term, but we need this term to be multiplied or producted with the fi and then sum them. That's another application of sum product. So what we need to do then is to say var sample is going to be sum product of either way is the same. You can xi minus x bar square, then comma fi, or you can say fi, right, comma this square. All right, so this is the big summation, and then we want to divide it by n minus 1 over here. Okay, so that's our variance. And finally, we take the square root. So standard deviation of sample will get square root of V10, and that is our sample standard deviation. All right. So Excel doesn't really have a formula to handle this fi, the presence of fi, but now you know it. It's quite simple. Just use sum product, and life is easy. Okay. And finally, there's a variation, right? Variation is just basically the whole summation without dividing by the n minus 1. So we can do it, let's just do SSXX. Well, so we can copy the whole formula. Where's our variance? We can copy the whole formula, right, without dividing by the n minus 1. So that will be our SSXX, right? Or we know that the variance V10 multiplied by n minus 1 is going to be our SSXX anyways. So both ways will give you the same answer, 1022.222, which is exactly the case here. Okay, so I'll leave you with that, and see you in the next session.